Okay. So find the partial fraction decomposition of this rational function. So this factors as x plus 2 times x minus 2. So I'm going to have x plus 2, x minus 2, a, and b. It doesn't matter if you started yours out and you had b over x plus 2 and a over x minus 2. It doesn't matter. You're going to get the same thing in the end. Okay. Okay, so multiply. So I would need to multiply the first one by x minus 2 over itself. I'd multiply the first one by x plus 2, or the second one by x plus 2 over itself. Okay, so when I'm just talking about the numerator, I get a times x minus 2, so ax minus 2a. And then I have b times x plus 2, so bx plus 2b. And it's all over x squared minus 4. So we don't worry about the x squared minus 4 part. So I'll just leave it off completely.
Equals 4.
Yep, it equals your original numerator, which Brian's telling me is 4. So that came from here. Set up your two equations. Kwame, what are my two equations?
The two equations would be the one with A and one with B. We stack them on top of each other.
Stack them on top of each other. What do you mean? So I have ax plus b. Well, leave off your x's. Just say a plus b. So those are the things with x's in them. Have to equal on the other side the thing with x's in them. There were no x's, so 0. And then the other one I have negative 2a plus 2b. Those are numbers, so it's going to equal 4.
Yeah, stack them on top of each other, see?
But I asked you for the equations.
Right.
Okay, multiply the top by 2. Or you could divide the bottom by 2. It doesn't matter. So I get 2a plus 2b equals 0. I have negative 2a plus 2b equals 4. So when I add straight down, my a's go away. I get 4b equals 4. So b is 1. Okay, I know b is 1. So Scott, if b is 1, what's a? Right, because a plus b made 0. So you can plug it in if you want. You get a equals negative 1. Okay, so your final answer, it's a negative 1. It looks like a 7. So your final answer puts negative 1 over the x plus 2, so negative 1 over x plus 2, plus b is 1, so 1 over x minus 2. That's it. That's the partial fraction decomposition. Okay, ready for the next one? So I get 2x plus 3 times 2x plus 3. That's what the bottom is. Okay, so when I set this up, I'm going to have 2x plus 3 for the first denominator. And it's a repeated factor, so write 2x plus 3 in parentheses and square. Okay, what goes on top of the first one? A. What about the second one? Just b, right? It's not bx plus c because this is a repeated factor, so we're really just looking at what was in parentheses. So 1 degree less than what was in parentheses.
But if you could break it up into 2x plus 3 times 2x plus 3, why can't you do A over 2x plus 3 plus B?
It doesn't work that way. It's weird, but that's why you need to know those 4 possible cases. Okay. Do you see what he's saying? So you can't just say like 2x plus 3 for both those denominators. It won't work out that way. Okay. So when I think about my numerators, I need another 2x plus 3 on the first one. Okay, so I would have a times 2x, so 2ax, plus a times 3, so 3a, plus b. All of that's going to equal the original numerator, which was 2x.
There's X's in this one.
Yeah, there's x's. So 2ax, that's the only thing with x, it has to equal 2x. So 2a equals 2.
A equals 1.
3a plus b, that equals the number. There's no number over there. So plus equals 0. So 3a plus b equals 0. Yeah, so Brian's saying a is equal to 1. So if I plug 1 in, I get 3 plus b equals 0. So b is negative 3. That's right. So your final answers are a is 1, so 1 over 2x plus 3. B is negative 3, so you can write minus and then put 3, or you can say plus and a negative, doesn't matter. 2x plus 3 squared. So you get that. Okay, making sense? See how you can integrate both of those? So you couldn't integrate the original. Well, actually, you could integrate the original. Yeah.
When you have A and B switch, what do you have to fix it?
No, you get the same thing in the end.
Okay.
Yeah. No, I guess you couldn't integrate the original because if you did a u substitution with the bottom, do you guys see? Look at your original. If I was trying to integrate this, a u substitution would give me du equals 8x plus 12. You can't replace that in your numerator, right? So that wouldn't work. But you can definitely integrate this second one that we just found, because you can do u substitutions for both. See why this is convenient? All right. Next one.
Yep.
So this bottom one factors, you can pull out an x, then you have x squared plus 4. Okay, that's an irreducible quadratic. You can't factor x squared plus 4.
Irreducible quadratic.
Yep.
Number 4. Or number 3. Is it repeated?
It's not repeated.
So it's number 3.
Okay, there's my two denominators, x and x squared plus 4. So on the top, above x I put a. Above x squared plus 4 I put bx plus c, right? So you need to find a, b, and c on this one.
Yeah, what's the bx plus c?
It's because it was x squared before. And it wasn't repeated or anything.
Like if it was x to the third plus x squared, would you have bx squared plus cx
Mm-hmm. Plus d.
plus d?
Yep. We don't do any with the 3 irreducible trino.
Well,
Try.
if we ever
Cubic.
stumble upon-
All right, here we go. So multiply by x squared plus 4 on the first one, x squared plus 4. Okay, multiply by x over x on the next one. Okay, so we're just talking about the numerator. So I'd get ax squared plus 4a when I multiply my a in. Then I'm going to multiply by x in,
My
so
numerator
think of
sucks.
parentheses. So I get bx squared plus cx. That's my whole numerator. It equals the original numerator. So 2x squared minus x plus 4. I'm hoping it's easy. It doesn't look like it's going to be super easy, but we'll see. It's not too bad. All right, so ax squared, bx squared, they add up to be 2x squared. So right away I know a plus b have to make 2. That's one of them. The next one, so let's look at our x's. Cx equals negative x. That was nice. So c equals negative 1. Okay, the last one, 4a equals my number, 4. So a is equal to 1. So I have a is 1, c is negative 1. Can you guys find a? Or b, I mean. b is also 1, right?
Minus 1.
Because you're plugging in a is 1. That wasn't too bad. All right, so when we have this, we're going to have a was 1, so 1 over x, plus b was 1, so 1x, or just x, I'll write x, plus c, so minus 1, all over x squared plus 4. And you can check that if you combined your fractions, you would get what you had originally. Okay. Yay. All right, D. Notice how I have 2x to the 4th. Okay, if you guys started out, notice how this does factor. You can do factor by grouping. But if you like combined your numerators, okay, I'm trying to think of the best way to say this. If you did all of this work, notice how you're always just getting, this was x squared. It's always 1 degree less than what you had on the bottom. This is 1 degree more. So when that happens, if you have your degrees equal or it's not 1 degree less, you need to do long division first. Okay, that's what happened on that homework problem where we had x squared over x squared plus 1. And I had you guys write it as 1 minus x squared over x squared plus 1. Because it was x squared plus 1 minus x squared. That's what happened on that. You do long division to get to that. Okay, so write yourself a note if it's the same degree. So if the same degree or more on the top, use long division. So if it's the same degree or more on top, use long division. Do you guys remember long division? It's been a while. Okay.
Another pink little box.
Nope, that's synthetic. No, why can't you use synthetic?
Because there's no over.
Yeah, it's not like x minus 1 on the bottom.
Yeah.
Not. So it wasn't like a single thing. So you have to use long division. All right, here we go. All right, so I'm taking my 2x to the 4th plus 4x cubed minus 2x squared plus x plus 7, and I'm dividing by x cubed plus 2x squared minus x minus 2. Okay, here's how you do long division. You look at this first term, x cubed. You say, what do I multiply x cubed by in order to get this first term over here, 2x to the 4th? So what do I need? 2x, right? Okay, so that gives me 2x to the 4th. Now I take my 2x and I multiply by everything in my divisor. So I have 2x to the 4th. 2x times 2x squared is 4x cubed. 2x times negative x is negative 2x squared. 2x times negative 2 is negative 4x. Okay, and then in normal division, you then subtract your numbers, right? So what I always say is I say draw the line, change the signs, because you're adding the opposite. So we're going to add straight down. So I'm just making all these signs the opposite of what they were. And I usually circle them so I know which one I need to change. Now I add straight down. So notice lots of things cancel, which is very nice. X to the 4ths are gone. X cubes are gone. X squareds are gone. So you get 5x plus 7.
To make that a remainder.
Yeah, then you would repeat. You would say, what do I multiply x cubed by in order to get 5x? But that's some kind of fraction. So this is our remainder. So we have remainder 5x plus 7. So later on when you guys got, let's say we had that. When you guys first learned about fractions, if you had 3 remainder 7, you would write it as 3 and 7 out of 9 are left. Same thing here. We're going to say our answer is 2x plus 5x plus 7 over what my divisor was. Okay, this is what we're going to do partial fraction decomposition on. So find that. Let me see where my time is.